Hey everybody, it's Locklan here. And so what we're going to be talking about is question number 5 from the 2012 Calc BC FRQ. And this is a logistic growth and separation of variables equations. Now, just immediately looking at this question, you can immediately tell that this is a separation of and logistic growth equation because it's from the equation given and also from the graph that's represented. It's a very recognizable graph in which it represents a sort of S curve as it approaches its limiting capacity. So now let's just read out like the context that is given to us. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time equals 0, when the bird is first weighed, its weight is 20 grams. And if B of t is the weight of the bird in grams at time t days after the first weight, then it gives us this derivative of the bird's weight. So a few questions that we can expect coming from this are questions about concavity, questions about separating variables, which is worth the majority of these points in these questions, as well as questions in context, meaning at like 40 grams or a certain weight, what does it actually mean for like the number that is produced. So let's just start off with the first part of the question, part A, and it asks, is the bird gaining weight faster when it weighs 40 grams or 70 grams? So I just want to ask, like, what are you thinking about?
This looks pretty complicated to me. I think it's gonna be, I don't really understand how to do these kinds of questions when it says compare them, because I don't know, I don't really get this topic very well.
All right, well, the first question, the first thing you can take away, it is talking about the sort of rate. It's asking about this faster. So that means that we can immediately recognize that we're looking at this dB over dt, or the derivative of the b function equation. And this question is actually very, very simple, as it simply comes down to plugging in variables. So because we can tell it's from this rate question, or like the derivative, as it's asking about this faster, we can simply plug in these two values, 40 and 70. So dB over dt evaluated at when b equals 40 is going to equal 12 grams a day. And the same value, dB over dt, the derivative, evaluated at b equals 70, is going to equal 6 grams a day. And what we can simply do is compare these two values, 12 grams a day at 40 grams, or 6 grams a day at 70 grams. And so we know that the bird gains weight faster when it weighs 40 grams. Additionally, there's another way to solve this conceptually. Of course, for the scoring reason, you have to use these two values and you have to compare the weight at 40 grams and 70 grams. But you can also think about this conceptually. So this equation and how logistic growth really works is that this is the slope of the graph of b of t. Obviously, it's the derivative.
Yeah.
And this b function is going to grow. It appears at 20 and it's going to close to and closer and closer and closer to 100. And so what that means is that as b approaches 100, what happens to this 1/5 100 minus b term?
If b approaches 100, would it go to infinity?
No. So if b approached infinity, that would be like negative infinity. But because b is approaching specifically the number 100, and it's barely less than 100, this is going to be a number that's approaching 0. Meaning, as time continues indefinitely, this slope is going to be approaching 0. And that's where that famous curve of that logistic growth, that S shape.
The asymptote thing?
Yeah, the asymptotal value comes from. And so really, conceptually, you can understand that earlier in the weight, when it weighs 40 grams, it's going to be a much faster rate of change, or much faster gaining weight than earlier at 40 grams than later at 70 grams. Do you understand that?
Oh, that makes so much more sense.
Yeah.
Okay, so Locklan, I know we just did part A and we did the math for that, but now I'm looking at this graph and it just makes it look so much easier than doing whatever we did in part A. Why can't we just use this graph to do it?
So I understand that you may be thinking like the rate of change here is much greater than the rate of change later, and that can be used to prove like that 40 versus 70 gram argument. However, what you must do is read through all parts of the question, which is A, B, and C, before you should have started A, which is my fault for not telling you to do that earlier. So in part B, if you actually fully read through it, the first part is asking to find the second derivative, and the second part is asking to explain why the graph is incorrect and does not match b of t. If a lot of people, and it's a common way to easily lose points or waste time, is they do part A and use reasoning from the graph, and once they get to part B, they realize this graph is incorrect and they waste all that time, or they don't even bother going back to part A, which is an easy way to lose points. So that's why you cannot use these graphs. Additionally, it's a very, very common part B question or later in these logistic growth questions where they give you a graph and ask to prove why it's incorrect. So let's just get into this. The first part is to find the second derivative of b of t. So can you try your best to do that?
I think so. I think I remember how to do this. We do the 1/5 on the outside, and we're gonna have to use chain rule. So we get the 1/5, and then it just looks like b on the inside, but we have to multiply it by the 1/5 again because of the chain rule thing. So we get the 1/5 times the 1/5. We get the 100 minus b. So
All right.
we get 1/25 times 100 minus b. Is that right?
Yeah, so I see what you did there. You recognize that when you derive b, it's going to become the derivative. So you can simply plug in this original term for b prime.
That's what you're supposed to
So you did 1/5 times b prime. However, what you missed was this very important negative, which is a very, very common way of losing points on this chain rule. It's called the chain rule because you have to remember that there's this hidden -1 in front of this term. So really, you were so close, but slightly far away. All you have to do is slap on a -1 up here, as that represents the negative b value. So the actual answer is -1/25 times 100 minus b is equal to the second derivative. So now, I'm going to ask you, now that we have the second derivative, how can we use this to prove why this graph is incorrect? And what do we know about second derivatives and concavity? That's an easy way to do this.
So I know that when the second derivative is negative, that means the first derivative is decreasing, right?
Mm-hmm.
And doesn't that mean the original graph is concave down
So
when the second derivative is negative?
yeah, because this b term is always between 20 or approaching 100, that means this inside term is always going to be positive. And that means when it's multiplied by this -1/25, that the second derivative will always be negative or concave down. So what that means when we look at this graph is, does the graph agree or disagree with that? Are there any points where it's concave up?
It looks like from 20 until about here, so from this point to about this point, we'll say, it looks like pretty concave up to me.
I would say so. So congrats with that, you were right, and you managed to prove that in one sentence, you managed to prove this graph incorrect. As you can say, the second derivative is always concave down, and there are parts in the graph that are concave up. Therefore, the graph does not correctly align with b of t. Good job.
So it's taken a while to get here, but we finally made it. We're on to part C. So we gotta use something called separation of variables to find b of t, and it looks like we're given the derivative in the initial condition. So how do we go about that?
All right, so Henry, in the very beginning, when we first identified the type of question we were dealing with, I called it a logistic growth and separation of variables problem. So separation of variables is where a majority of the points come from in this FRQ. If you look at the scoring rubric, it's actually worth 5 points. And you can also realize if it's only worth 3 parts and the first 2 parts were decently quick, of course, this is where all of the marbles, all of the points are going to be. So separation of variables is a method of integrating derivatives that are slightly more complex. And so what we can do is, or what do you think?
To me, the dB over dt looks a little bit like a fraction. Does it have anything to do with that?
Exactly so. As you recognize, a lot of integrals require that dB and dt on the sides are properly integrated. So what we're going to do is first move the b terms and the non-b terms to either side. So what we're going to do is we're going to divide the left-hand side by 1/100 minus b. dB is equal to 1/5 dt. And now that right here, I'm sure you recognize a lot of integrals. What can we do to both sides to?
So the left one looks like some form of natural log, or
Yeah.
because we gotta integrate both sides, as you said earlier. And the left one looks a bit like a natural log integral. But I remember I made a mistake in an earlier question.
Yeah.
So I need to remember to not forget that negative when I'm integrating that.
So let's first integrate the left-hand side. And what's the specific method that you forgot to use correctly?
So earlier I left out the negative sign when I was finding the second derivative.
Yeah.
So I don't want to leave out the negative sign this time.
Yeah.
So I think I'm going to take it out.
So you're going to remember that negative natural log of the denominator, 100 minus b. And you don't have to include the plus c, even though this is an indefinite integral on the left-hand side, where that b or y value is, because on the right-hand side, where our x or our is where plus c would be. equals, what would this be?
1/5 is easy. That's
Yes.
just a constant, so it'd just be t over 5.
Yeah, t over 5, and then that's where we include the plus c.
Yeah, that makes sense.
And so now, right now, we are looking at an indefinite thing as it has a plus c. What was given to us in the very beginning that we can now use to find that c value?
So we know that when t equals 0, b is 20.
Yeah,
So can we just plug that in?
that's it. That's all you have to do.
Wow.
So the natural log of 100 minus 20, let's just say 80, is equal to t, which is 0, and over 5 plus c. And this is just 0, so c is equal to the negative natural log of 80. All right, Henry, so now that we're given what y is equal to and what c is equal to, do you think that you can finally truly find b of t?
I think I can try. So I'm going to rewrite the equation with all the variables plugged in, knowing that c equals negative ln of 80.
And you can also drop the absolute value to just parentheses as you recognize 80 is always.
And now, I think I recognize this from an old question. So we can set e to the power of both sides. So we get e to the negative ln of 100 minus b equals e to the power of t over 5 minus ln of 80. But I'm not going to write that out right now because most of that stuff actually drops back down. Since e to the power of ln of something is just that thing, we actually get negative 100 plus b is equal to negative 80 times e to the power of t over 5. And b is super easy to solve from there. You just add 100 places. In order to get b of t is equal to 100 minus 80 times e to the t over.
That's great. So you did a great job going through this question, and you fixed your earlier mistake of forgetting the chain rule. As the chain rule is commonly like the most questioned concept in these types of questions, because it's so easy to forget this negative b, and when dealing with it, raising both sides with the power of e and forgetting that negative. And so great job, Henry. You're now done with all parts of this question, A, B, and C. And so congrats, you did a great question with logistic growth and separation of variables. And a few reminders of things you should do is remember to read all parts of the question, A, B, C, D if there is one, because a very common concept question is that just disproving or proving the graph, and remembering you have to read all parts. Thank you for watching our video on me teaching Henry logistic growth and separation of variables in the 2012 FRQ Calc BC number 5.